going to work out section 14.2 number 21 is on double integration over non-rectangular regions. Here we're trying to integrate the function x times y over the region enclosed by these curves square root of x, y equals 6 minus x, and y equals 0. So we see the region is described right here. Okay, again, this is a region that's not a rectangle, so you can't directly apply Fubini's theorem. You got to come up with a double integral, in which an iterated double integral where your limits of integration are going to depend on either x or y. Now there's a preference of which way we're going to want to do this, because if we try to do it the most probably natural way, which is dy dx, that is fix an x value between say 0 and 6 for our region and let y range from the bottom to the top, well, the top of this changes as we run across this interval 0 to 6. Part of the time it's y equals x square root of x. Part of the time it's y equals 6 minus x. So that's not good. That would result in two double integrals for us to compute, and we don't want to do that. So let's go instead and slice from left to right. Okay. So we're going to fix a value for y, and then we're going to let x, for that fixed y, we're going to let x range from the left to the right hand side of our region. Now we need to know what those corresponding left and right hand sides are, what those x values are, so we need to solve each of these equations for x. So we get x equals y squared and x equals 6 minus y. Now when we do our slice, we fix a y between 0 and 2, and we're going to let x range from the left to the right hand side of our region. That's from x equals the square root, x equals y squared for a fixed y, the corresponding x on the graph, corresponding to our point on the graph, is x equals y squared. The rightmost portion of this segment is corresponding to x equals 6 minus y. Alright, so we're going to do that for each y between 0 and 2. Doing that leads us to this double integral here. Now we're just going to compute it. Once we've got it set up, it's just a computation. So now we're going to find our antiderivative. We're going to first find our antiderivative of our function with respect to x. So we treat y as a constant. So we're just going to leave it alone. It's going to come along for the ride. The antiderivative of x is 1/2 x squared, and then multiply by the constant y with respect to x. And then we evaluate that from x equals y squared to x equals 6 minus y. Plug in those for x and subtract. And now we're getting the integral from 0 to 2. The 1/2 can come out in front. And then we're going to plug in 6 minus y for x. So we get 6 minus y squared times y, minus plug in y squared for x. So we get y squared squared times y. And now we're left with just a dy integral. So once we get past that first step, it pretty much becomes a Calc 1 problem. We've got to find the definite integral from 0 to 2 of this function. So we've got to multiply it out. It's really just a polynomial. So we're going to square out the binomial 6 minus y to get 36 minus 12y plus y squared times y minus y to the 4th times y dy. Now multiplying your y through, we get 1/2 times the integral from 0 to 2 of 36y minus 12y squared plus y cubed. And then lastly, we've got y to the 4th times y, which is y to the 5th power. Alright, so we're just going to integrate term by term, find your antiderivative term by term. Don't forget about the 1/2 in front. We get 1/2 times 36 times the antiderivative would be y squared over 2. 36 over 2, though, is 18. So what we're going to have here is 18y squared. And then similarly, when we look at the antiderivative of y squared to our 12y squared, it's going to be 12 times y squared over 3, or 1/3 y squared. 1/3 times 12 is 4, plus 1/4 y to the 4th, minus 1/6 y to the 6th. And then we evaluate that, our antiderivative, from 0 to 2. So we're going to plug in 2 for y, plug in 0 for y, plugging in 0, everything goes away, everything is 0. We square it or cube it or raise it to the 4th power, what have you. So we just really got to plug in 2 for y, simplify, and we're done. So we get 18 times 4 minus 12 times 2 cubed, which is 8. We get 18 times 4, then minus 4 times 8 plus 1/4 times 2 to the 4th, which is 16, minus 1/6 times 2 to the 6th, which is 64. And if you work all this through, not everything divides in evenly. You end up with a fraction here. You end up with 50/3 for this particular problem.